Welcome to an introduction to statistics, brought to you by Parkbench Tutors and narrated by David Hopcroft. For further information about Parkbench Tutors, please visit parkbenchtutors.com. In this podcast, we will continue to look at definition of means and some worked examples. To recap from the previous podcast, the arithmetic mean of a set of measurements is the sum of the measurements divided by the total number of measurements. We express this using mathematical notation. X bar was equal to sigma from 1 to n of x divided by n. This could be simplified to x bar equals x1 plus x2 to xn divided by n. Here is a typical calculation for arithmetic mean, which also shows the weaknesses of this measurement. We find the arithmetic means of the incomes for 6 students. X bar equals 66,000 divided by 6, which comes to $11,000. This clearly does not really reflect the incomes of any of our students. Most are well below this figure, and one is considerably above this figure. How much a figure differs from the arithmetic mean is called a deviation. Since some figures will be above and others below, it is not surprising to find the sum of all the deviations must be 0. In notation form, the sum of the deviations is equal to the sum of the differences between the numbers and the arithmetic mean. We can express this in different ways, but the important point here is to remember that the sum of all the deviations will still be equal to 0. Now let us look at the geometric mean. For any set of numbers, x1, x2 to xn, the geometric mean is the nth root of the products of all the numbers. So g equals the nth root of x1 multiplied by x2 multiplied by up to xn. We shall work through an example. We will find the geometric mean of 2, 4 and 8. G is equal to the cube root of 2 multiplied by 4 multiplied by 8. G is equal to the cube root of 64, which gives us an answer of G equal to 4. If there is a large series of numbers, then you might wish to make use of a scientific calculator. To find the geometric mean of 3, 6, 8, 12 and 17, we take the fifth root of the product of 3, 6, 8, 12 and 17. This gives us an answer of 7.827. On a scientific calculator, you will find a key which is labelled the y root of x. Enter the product and then press this key. We can do the same calculation using logarithms. We want to find the fifth root of 3, 6, 8, 12 and 17. First work out the product. G is the fifth root of 29,376. Using logarithms, the log of G is 1/5 the log of 29,376. This becomes 1/5 multiplied by 4.4679, which equals 0.89359. Now we need the antilog of this number, which gives us an answer of 7.827. We can also find the geometric mean for frequencies of measurements, just as we earlier determined the arithmetic mean for frequencies of measurements. G is equal to the nth root x1 multiplied by x1 multiplied by x10 for f1 times up to xn for fn times, which we can rewrite as the nth root of x1 to the power of f1 multiplied by x2 to the power of f2 up to xn to the power of fn, where large N equals the sum of the frequencies. If all the numbers are positive, then the log of the geometric mean is 1 over n, the log of x1 to the power of f1, all the way up to xn to the power of fn. We can expand this and say that the log of g is equal to 1 over n, f1 multiplied by log x1, all the way up to fn multiplied by the log of xn. So that log g becomes the sum of fi log xi divided by the sum of fi. A useful formula is that to determine the averages for compound interest. If the average interest equals Q and the initial deposit is $1,000, after 1 year the amount of money we have is $1,000 plus Q times $1,000, which is the same as 1,000 times 1 plus Q. After 2 years, the amount will be 1,000 times 1 plus Q plus 1,000 times 1 plus Q times Q, which is 1,000 times 1 plus Q squared. So, after n years, the amount becomes 1,000 times 1 plus Q to the power of n. We can now write a general formula of m is equal to a multiplied by 1 plus q to the power of n, where m is the final amount after n years and a represents the initial deposit. There are situations where some numbers have more influence than others, which we can refer to as being weighted. We start with numbers x1, x2, all the way up to xn, and we weight these by w1, w2, all the way up to wn. X bar, the arithmetic mean, becomes x1 multiplied by w1 plus x2 multiplied by w2, all the way through to xn multiplied by wn, all divided by w1 plus w2 all the way through to wn. We can write this using our sigma notation. X bar equals sigma xn multiplied by wn divided by sigma wn. Let us look at a worked example for this. A new driving test has 3 components: a theory exam, a practical test weighted at twice the theory test, and a night driving test weighted at 4 times the theory test. Jessica scores 60 points on theory, 55 points on practical, and 60 points on night driving. What is the weighted mean? The weighted mean is 60 multiplied by 1 plus 55 multiplied by 2 plus 60 multiplied by 4 divided by 7, which gives us an answer of 58.57. The harmonic mean for any series of numbers is the reciprocal of the arithmetical mean of the reciprocal of the numbers, which we can write as 1 divided by 1 over n multiplied by sigma 1 over xi. We can simplify this to n divided by sigma 1 over xi. Let us look at an example here. We want the harmonic mean of four numbers, 4, 7, 8 and 9. So h equals 4 divided by 1 over 4 plus 1 over 7 plus 1 over 8 plus 1 over 9. This gives an answer of 6.36. Finally, the root mean square, or the quadratic mean. We can see here we have the root of x bar, which is the mean, raised to the power of 2, which is the squared part. This equals the root of sigma xi squared divided by n. Let us work through an example and find the root mean square of 3, 4 and 8. So we need to plug figures into the formula. We want the root of 3 squared plus 4 squared plus 8 squared divided by 3, which is the root of 9 plus 16 plus 64 divided by 3, which is the root of 89 divided by 3, which will be the root of 29.66, giving us a final answer of 5.45. This ends our fourth podcast on statistics, brought to you by Parkbench Tutors and narrated by David Hopcroft. Thank you for watching and for listening. We wish you success in your studies. For more information about Parkbench Tutors, please visit parkbenchtutors.com.